सस्टेनेबल सोइल्स म्यानेजमेन्ट है त। सस्टेनेबल सोइल म्यानेजमेन्ट एसएसएस। सस्टेनेबल सोइल म्यानेजमेन्ट इन्भल्भ्स के त practice and principle that maintain and improve soil health, minimize environmental impact, and ensure long-term agriculture productivity. It support ecosystem service like water filtration, nutrient cycle, and biodiversity. Water filtration, nutrient cycle, and biodiversity, and इम्पोर्टेन्स इन नेपाल। नेपालमा यसको इम्पोर्टेन्ट के छ भन्दाखेरि नेपाल डाइभर्स टोपोग्राफी एन्ड क्लाइमेट मेक्स सोइल प्रोन टु इरोजन एन्ड डिग्रेडेसन एन्ड न्युट्रिएन्ट डिप्लिसन। सस्टेनेबल म्यानेजमेन्ट इन्स्योर फर्टाइल resilient soil and long-term land productivity. प्रिन्सिपल अफ सस्टेनेबल सोइल म्यानेजमेन्ट के प्रिन्सिपलहरू हुन्छन् भनेपछि प्रोटेक्ट, रिस्टोर, मेन्टेन इकोसिस्टम सर्भिस एन्ड क्वालिटी एन्ड इन्हान्स सोइल प्रोडक्टिभिटी एन्ड नलेज एन्ड इनोभेसन, एवारनेस एन्ड कम्युनिकेसन। प्रोटेक्ट सोइल। अब सोइल कसरी प्रोटेक्ट हुन्छ भन्दाखेरि प्रिभेन्ट फिजिकल, केमिकल एन्ड बायोलोजिकल degradation, present physical, chemical and biological degradation, control erosion and avoid deforestation, rehabilitation degraded standard and marginal land, maintain ecosystem service, ensure soil supports water availability and quality, enhance soil activity, improve soil fertility according to its natural capacity, and knowledge and innovation, develop extension service knowledge system and promote innovative techniques, awareness and communication, educate communities on the importance of soil conservation, practice for land productivity conservation in Nepal। प्र्याक्टिस चाहिँ र पर्पोज एन्ड बेनिफिटहरू के छन्। practice diversify crop rotation, practiceहरू diversify crop rotation, reduce pest and disease pressure, balance nutrient use and legume crop production, fix atmospheric nitrogen, improve soil fertility, soil cover crops mulching and protect against erosion, conserve moisture, retention of crop residue, aid organic matter, improve soil nutrient, soil structure, and organic measure, compost, green manure, enhance soil fertility and microbial activity, efficient use of inorganic fertilizer and prevent nutrient loss and soil pollutions, minimum zero not tillage, reduce soil disturbance, prevent erosion, agroforestry practice, integrates tree with crops, improve soil structure and biodiversity, and avoidance of toxicities, prevent heavy metal or chemical contamination, maintenance of soil properties, preserve physical, chemical and biological health of soil, and key takeaway, protecting and enhancing soil is crucial for agriculture, forestry and watershed management, and Nepal steep hill and fragile ecosystems require integrated soil conservation practice and combining vegetatives, mechanical and chemical approaches ensure sustainable land productivity, and basic concept of hydrological cycle and its relationship to watershed management। hydrology and hydrological cycle हेरौँ। हाइड्रोलोजी भने साइन्स अफ वाटर अन अर्थ, स्टडी इन मुभमेन्ट, distribution and quality, hydrological cycle, water cycle, continuous recycling of water between atmosphere, land and ocean, and processes involves चाहिँ के हुन्छ भन्दाखेरि इभापोरेसन हैन पहिला इभापोरेसन water from ocean, river and land turn into vapor, condensation, precipitation, water vapor from cloud and fall as rain or snow, runoff flow, water move over land to land to land to rivers, stream, lake, or infiltrates into soil, groundwater flow, subsurface water moves back towards oceans, basic equation, input output, input minus output is equals to change in storage, and figure चाहिँ conceptual चाहिँ सन इभापोरेसन सन हुन्छ त्यहाँबाट इभापोरेसन हुन्छ एटमोस्फियर हुन्छ प्रिसिपिटेसन ल्यान्ड त्यसपछि रन अफ ओसियन र साइकल रिपिटेड हुन्छ वाटरसेड एन्ड वाटरसेड म्यानेजमेन्ट एन एरिया बाउन्डेड बाई अ drainage divide where all water drain into a common outlet, stream, river and lakes function as a complete hydrological systems. Watershed management भनेको rational utilization of land and water resources for maximum production and with minimum hazard, and include forestry, agriculture, soil conservation and water management practice, and factor hydrological characteristics of a water, factor effect of hydrology and watershed, size large watershed and high runoff volumes, hydrographs deficit flow rates, and shape चाहिँ in elongated shape चाहिँ hydrological characteristic of watershed, size चाहिँ यस्तो हुन्छ, shape चाहिँ elongated हुन्छ, longer time of concentration, lower peak runoff, square faster peak of flow. अब स्लोपमा चाहिँ स्टेपर स्लोप्स, हाइजर runoff velocity र more erosion potential, and soil and geology determine infiltration, fertility and landslide susceptibility. Weak geology plus rainfall हैन 75% चाहिँ landslide in Nepal. Okay, and vegetation cover, dense vegetation, reduce runoff, erosion and sediment load, increase infiltration, and drainage pattern and density affect water movement, affect regards water movement. Drainage density is equals to total stream length by catchment area, and climate factors, precipitation, temperature, humidity, wind, sunshine affect runoff, evapotranspiration and erosion. Socio-economic factors like agriculture, deforestation, mining, fire, shifting cultivation, and after water flow and sediment load. Relationship between watershed management and river hydrology. Benefit of watershed management चाहिँ gradual runoff flow, एकदम gradual runoff flow, and reduce peak flow and flood. Peak flow and flood को risk reduce गर्छ. Enhance groundwater recharge, sustain base flow river, reduce sediment load and improve water quality, prolonged river flow, support irrigation, fishery and ecology, and vegetation and conservation structure, and check dam, terrace, bioengineering, slow runoff, control erosion and stabilized slopes. Comparison चाहिँ manage watershed, lower peak flow and less sediment, improve water quality, control flood, and unmanaged watershed, flash flood, high sediment load, poor water quality and soil degradation. Importance and relationship of watershed management with हार्भेस्टिङ एन्ड डेभलपमेन्ट एक्टिभिटिजमा चाहिँ हाम्रो वाटरसेड म्यानेजमेन्ट ओभरभ्यू चाहिँ comprehensive administration of land, water and vegetation to maximize benefit for local community, interconnected system, land, water र vegetation. Proper management in one domain affect the other positivity. And important of watershed management चाहिँ watershed management को इम्पोर्टेन्टहरू livelihood improvement, water resource development. livelihood improvement चाहिँ provide food, fodder, fuel wood, timber and water, reduce erosion and improve soil and water availability. Water resource development, enhance water availability and reduce sedimentation for irrigation, drinking water and other uses. And infrastructure protection, protect hydropower plant, irrigation system, road and trails, river drainage works and lakes and reservoirs from erosion and sedimentation. Disaster reduction mitigation, reduce soil erosion, slope failure and flood risk. Climate change adaptation, address of too much or too little waters, flood and drought. And relationship with water development activities. Okay, relationship between water development activities चाहिँ irrigation, align role of watershed management, the effect. Irrigation, align watershed management with irrigation system management and effect. Ensure year round water supply, improves crop productivity and sustainability. And hydropower, glacier fed Himalayas watershed are critical. Management reduce sedimentation and enhance flow reliability and increase electricity, green generation potential and protect hydropower infrastructure. And drinking water मा चाहिँ integrated management, maintain water quality and quantity despite human, livestock and agriculture pressure, ensure safe, reliable drinking water and reduce treatment cost. And watersheds are source of irrigation, hydropowers and drinking water. Management resource erosion, sedimentation and disaster risk. Proper watershed management ensures sustainable water supply and support climate resilience. And integration of land, water and vegetation management is essential for development activities. Soil formation, parent material, soil profile and texture. Soil profile, pedogenesis है त. Soil formation, pedogenesis. Soil formation is the process of transforming parent rock or organic matter into soil through weathering and decomposition and biological activity. It is a long-term process that may take millions of years to form a thin soil layer. Soil formation equation चाहिँ सोइल भने F CLO RPT, and C भने climate, temperature and rainfall. Organic matter, plant, animal, microbes. R relief, topography, slope, altitude. P parent material, rock, mineral, source. T time, duration of soil formation. And 2 मा छ फ्याक्टर एफेक्टिङ सोइल फर्मेसन. 1 मा छ प्यारेन्ट मेटेरियलले असर गर्छ, टाइमले असर गर्छ, क्लाइमेटले असर गर्छ, रिलिफ टोपोग्राफीले, अर्गानिक म्याटरले. है त यसको विषयमा पढौँ. प्यारेन्ट मेटेरियल, सोर्स अफ मिनरल एन्ड फिजिकल ट्रेट, कलर, टेक्सचर एन्ड स्ट्रक्चर. एन्ड नेपाली कन्टेक्समा रेड स्यान्ड स्टोन्स, रेडिस सोइल, ग्रेनाइट्स, कोर्स टेक्सचर सोइल्स. एन्ड अर्को छ टाइम, ओल्डर सोइल undergo more transformation, younger soil resembles parent rocks. Older Tarai soil rich in alluvial beam, high mountain soil still young and shallow. And climate चाहिँ temperature and rainfall affect chemical weathering, organic matter runoff and erosion. Warm and humid तराई, हाइजर अर्गानिक म्याटर, हाई माउन्टेनमा स्लो वेदरिङ, थिन सोइल्स. ओके, त्यसपछि चाहिँ हाम्रो रेनफल, रिलिफ एन्ड टोपोग्राफी, स्लोप एफेक्ट, रनअफ, इरोजन एन्ड सोइल डिपोजिसन. स्टेप हिमालयन स्लोप, थिन लस फर्टाइल सोइल, भ्याली फ्लोट फर्टाइल, एलुभियल डिपोजिट. Organisms, plant, animal, microbes contributes organic matter, aeration and decomposition and nutrient cycle. Forest in hill, rich humus, treated agriculture, earthworm activity improve fertility. And parent materials of soil चाहिँ definition, material from which soil originated, can be minerals, rocks or organic peat and humus. Determines color, texture, structure and fertility. And example in Nepal, okay, alluvium, granite and gneiss, sandstone, volcanic rocks. alluvium चाहिँ fertile तराई soils, granite and gneiss, coarse sandy hill soils, and sandstone चाहिँ radish soils, rich in nutrients and loss commons. And soil profile चाहिँ definition, vertical section showing layers horizontal of soil, OAEBCR, organic layer हुन्छ, leaves, humus, decayed matter. ए भने टप सोइल हो, मिनरल प्लस अर्गानिक म्याटर, फर्टाइल एन्ड डार्क हुन्छ. ई भने इलुभिएसन लेयर, लिचिङ अफ क्ले, मिनरल, लाइट कलर. एन्ड बी सबसोइल, एकुमुलेसन अफ क्ले, मिनरल, लस अर्गानिक म्याटर. सी भने वेदर्ड प्यारेन्ट मेटेरियल्स, partially distinguished, partially disintegrated rocks. And are भने bedrocks, unweathered rocks beneath the soils. And 5 मा छ soil particles and size classes. And sand, silt, clay 0.05 to 2 mm, 0.0022 to 0.05 र 0.002 भन्दा सानो चाहिँ क्ले हुन्छ. स्यान्ड कोर्स, गुड ड्रेनेज, त्यसपछि लो फर्टिलिटी हुन्छ. र सिल्ट चाहिँ स्मुथ हुन्छ, रिटेन मोइस्चर चाहिँ रिटेन गर्छ र मोडरेट फर्टिलिटी हुन्छ. अब क्ले चाहिँ फाइन हुन्छ, हाई वाटर रिटेन्सन हुन्छ र न्युट्रिएन्ट रिच चाहिँ क्लेमा हुन्छ. है त. अब अर्को आयो अब र बट पोर ड्रेनेज केले चाहिँ पोर ड्रेनेज हो है त। त्यसपछि सोइल टेक्सचर होइन, टेक्सचर एन्ड क्लासिफिकेसन। सोइल टेक्सचर proportion of sand, silt and clay in soil. सोइल टेक्सचर टेक भनेपछि स्यान्ड सिल्ट एन्ड क्ले भने टेकबहादुर हो। डिटरमाइन्स वाटर रिटेन्सन, पर्मिएबिलिटी एन्ड फर्टिलिटी। टेक्सचर क्लासेस युएसडिए, स्यान्ड सिल्ट एन्ड क्ले युएसडिएका आधारमा। सिल्ट स्यान्ड सिल्ट एन्ड क्ले, स्यान्डी एकदम स्यान्डी के भन्नुपर्छ भने चाहिँ 50-10-5 भने स्यान्डी हो। 50-10-5 सरी 85-10-5 भने यो स्यान्डी भयो। वेल ड्रेनेड हुन्छ, लो फर्टिलिटी हुन्छ, लाइट सोइल हुन्छ। लोमी स्यान्डमा चाहिँ 70 देखि 90, 0 देखि 30, 0 देखि 15 होइन। 70 देखि 90, 0 देखि 30, 0 देखि 15, 70, 30, 15 यो चाहिँ लोमी स्यान्ड है त। गुड ड्रेनेज हुन्छ, लो मिडियम फर्टिलिटी। स्यान्डी लोम, अब स्यान्डी लोम चाहिँ 43 देखि 85, 50 देखि 0 देखि 50, 0 देखि 20 चाहिँ फर्टाइल हुन्छ, इजी हुन्छ, इजी टु कल्टिभेट हुन्छ। एन्ड लोम चाहिँ अब लोम भने कस्तो भन्दाखेरि 40-40-20 लोम हो है त। स्यान्ड सिल्ट क्ले चाहिँ 20 हुन्छ, 40-40-20। आइडियल फर एग्रिकल्चर ब्यालेन्स प्रपोर्सन, आइडियल फर एग्रिकल्चर ब्यालेन्स प्रपोर्सन। सिल्ट लोम 0 to 50 र 0 to 25 स्मुथ हुन्छ, हाई वाटर रिटेन्सन हुन्छ र फर्टाइल हुन्छ। क्लेमा चाहिँ 0 to 45, 0 to 40 र 40 भन्दा बढी। पोर ड्रेनेज, हेभी न्युट्रिएन्ट रिच हुन्छ है त। पोर चाहिँ ड्रेनेज हुन्छ र हेभी न्युट्रिएन्ट रिच हुन्छ। त्यसपछि नेपाल कन्टेक्समा चाहिँ तराई सोइल मोस्टली एलुभियल लोम, फर्टाइल फर राइस, wheat and maize, fertile for rice, wheat and maize, and hill soil चाहिँ स्यान्डी लोम टु लोम है। हिल्स स्यान्डी लोम टु लोम, मोडरेटली फर्टाइल, युज फर ट्रेस क्रप्स। एन्ड माउन्टेन सोइल्स भने थिन हुन्छ, स्टोनी हुन्छ, लस फर्टाइल हुन्छ र लिमिटेड एग्रिकल्चर मोस्टली फर्टाइल हुन्छ। अब समरी पोइन्ट फर लोकसेवा चाहिँ सोइल फर्मेसन, वेदरिङ अफ प्यारेन्ट रक प्लस अर्गानिक म्याटर। वेदरिङ अफ प्यारेन्ट रक प्लस अर्गानिक म्याटर, अर्गानिक म्याटर प्लस टाइम प्लस क्लाइमेट प्लस organism प्लस स्लोप्स। एन्ड प्यारेन्ट मेटेरियल्स डिटरमाइन कलर, टेक्सचर एन्ड फर्टिलिटी। सोइल प्रोफाइल भने OAE BCR हराइजन। एन्ड सोइल पार्टिकल्स भने sand, silt and clay determine soil texture, and soil texture affect water retention and fertility and crop suitability. Nepal soils तराई फर्टाइल एलुभियल। अब नेपाल सोइल चाहिँ तराई फर्टाइल एलुभियल, हिल एन्ड हिलमा चाहिँ लोमी, तराईमा फर्टाइल हुन्छ, एलुभियल हुन्छ र हिलमा लोमी हुन्छ। माउन्टेनमा स्यालो र स्टोनी, हिलमा हाम्रोमा लोमी हुन्छ र माउन्टेनमा स्यालो स्टोनी। जियोलॉजिकल प्रोसेस, सोइल प्रोफाइल, सोइल प्र्याक्टिस एन्ड सोइल टेक्सचर। जियोलॉजिकल प्रोसेस एन्ड देयर इम्प्याक्ट। डिफिनेसन चाहिँ geological process are natural event that occur on and within the earth over long time scales, millions of years, influencing landform, soil formation and न्यू नेचुरल डिसास्टर। त्यसपछि गएर मेल्टिङ चाहिँ इम्प्याक्ट चाहिँ क्रिएट म्याग्मा एन्ड लिड टु भोल्कानिजम्स, क्रिएट म्याग्मा एन्ड लिड टु भोल्कानिजम्स। डिफोरेस्टेसन चाहिँ डिफर्मेसन चाहिँ कज अर्थक्विक ल्यान्डस्लाइड एन्ड सब्सिडेन्स र भोल्कानिजम्स। आइसोस्ट्याटिक्स एडजस्टमेन्ट एन्ड बाउयान्सी होइन, लिड टु अर्थक्विक्स एन्ड ल्यान्डस्लाइड एन्ड सब्सिडेन्स। ओके, वेदरिङमा चाहिँ ब्रेक डाउन रक्स कन्ट्रिब्युट टु ल्यान्डस्लाइड एन्ड सब्सिडिज एन्ड इरोजनमा चाहिँ रिमुभ सोइल कज ल्यान्डस्लाइड एन्ड सब्सिडेन्स एन्ड फ्लडिङ। एटमोस्फेरिक सर्कुलेसन इन्फ्लुएन्स हुरिकेन्स influence hurricanes, tornadoes and flooding. Soil profile, a vertical cross section of soil having layer horizon parallel to surface and is differing in physical, chemical and biological properties. Horizon OAE BCR, O horizon organic layer, humus, leaf litter, डिकम्पोज अर्ग्यानिक म्याटर। अब ओ होराइजनमा चाहिँ ह्युमस हुन्छ, लिफ लिटर हुन्छ, डिकम्पोज अर्ग्यानिक म्याटर हुन्छ र टप मोस्ट लेयर हुन्छ रिच इन न्युट्रिएन्ट्स हुन्छ। ए टप सोइलमा चाहिँ मिनरल प्लस ह्युमस र मोस्ट फर्टाइल लेयर थियो, बेस्ट फर प्लान्ट ग्रोथ। इलुभिएसन लेयर चाहिँ लिच्ड मिनरल्स एन्ड अर्ग्यानिक zone of elevation matter and zone of elevation matter and common in forest। त्यसपछि बी सबसोइल्स चाहिँ accumulated clay, mineral and metal soil, metal salt, accumulated clay, mineral and metal salt, zone of elevation र denser than topsoil। सी प्यारेन्ट मेटेरियल चाहिँ पार्ट्सली वेदर रक अर अनकन्सोलिडेटेड मेटेरियल्स, सोर्स अफ मिनरल फर ए एन्ड बी होराइजन्स। एन्ड त्यसपछि गएर आर भनेपछि बेड रक्स, अनवेदर्ड सोइल रक्स बेस्ड अन सोइल प्रोफाइल, नो अर्ग्यानिक म्याटर। अब सोइल प्र्याक्टिस एन्ड साइज क्लासेस चाहिँ डिफिनेसन चाहिँ सोइल प्र्याक्टिस आर द स्मल सोलिड कम्पोनेन्ट अफ सोइल क्लासिफाइड बाई सोइल। एन्ड स्यान्ड भने चाहिँ 2 देखि 0.05 युएसडिएको आधारमा लाइट सोइल एन्ड लार्ज पार्टिकल्स गुड ड्रेनेज लो फर्टिलिटी। एन्ड सिल्ट भने चाहिँ 0.05 to 0.002 मिडियम एन्ड स्मुथ टेक्सचर, रिटेन वाटर, मोडरेट फर्टिलिटी। एन्ड क्लेमा चाहिँ 0.002 भन्दा कम, हेभी सोइल, फाइन पार्टिकल्स एन्ड हाई वाटर रिटेन्सन, फर्टाइल बट पोर ड्रेनेज। एन्ड कम्पेरिजन विथ ISSS सिस्टम, स्यान्ड 2 to 0.02 mm, 0.02 to 0.002 mm एन्ड क्ले चाहिँ 0.002 mm भन्दा कम। सोइल टेक्सचर एन्ड टेक्सचर क्लासिफिकेसन डिफिनेसन, सोइल टेक्सचर इज द रिलेटिभ proportion of sand, silt and clay forming a parent characteristics of the soil। आइडियल सोइल टेक्सचर चाहिँ स्यान्डमा चाहिँ स्यान्ड, सिल्ट एन्ड क्ले। त्यसपछि गएर 40 र 20 optional for most crops. Important of soil texture: determine water retention, drainage, nutrient availability and workability. Influence erosion risk and sustainability for crops. And नेपाल कन्टेक्स्ट चाहिँ तराई लोम टु सेन्डी लोम, फर्टाइल फर राइस, वेट र मेज. एन्ड हिल सोइल चाहिँ स्यान्डी लोम, मोडरेट फर्टिलिटी एन्ड सस्टेनेबल फर टेरेस एग्रिकल्चर. एन्ड माउन्टेन सोइलमा चाहिँ थिन रक हुन्छ, लो फर्टिलिटी, मेनली फरेस्ट. बेस्ड अन द स्यान्ड, silt and clay component. There are 12 main soil texture classes which are shown below. USDA soil texture classes चाहिँ sandy soil चाहिँ sand, silt and clay 85 10 10 हैन, 85 देखि 100, 0 देखि 10 10 भयो भनेपछि भेरी कोर्स, ड्रेन क्विकली, लो फर्टिलिटी, लो वाटर रिटेन्सन. लोमी स्यान्ड, स्यान्डी सोइलबाट लोमी स्यान्ड हुन्छ 70 देखि 90, 0 देखि 30 र 0 देखि 15, स्लाइडली बेटर वाटर रिटेन्सन देन स्यान्ड, स्टिल लाइट कन्डिसन. अब स्यान्डी सोइलबाट लोमी स्यान्ड, अब स्यान्डी लोममा चाहिँ 50 देखि 70, 0 देखि 50, 50 देखि 70, 50 र 20 भयो र वेल ड्रेन हुन्छ, इजी टु कल्टिभेट एन्ड मोडरेट फर्टिलिटी. अब लोम आयो 40 देखि 50, 30 देखि 50 र 20 देखि 30, 50 50 30 40 30 20. ओके, लोमी भयो 40 20 30, आइडियल एग्रिकल्चर सोइल भयो. अनि सिल्ट लोम चाहिँ 0 देखि 50, 50 देखि 80 र 0 देखि 27 भयो. स्मुथ टेक्सचर एन्ड रिटेन वाटर वेल and fertile, prone to erosion. Silt 0.20, 80 देखि 100 र 0 देखि 12 भयो. फाइन टेक्सचर, होल्ड मोइस्चर्स, फर्टाइल्स, पोर ड्रेनेज. एन्ड स्यान्ड क्ले लोम चाहिँ 45 देखि 80, 0 देखि 28 र 20 देखि 35, हेभियर देन स्यान्डी लोम, रिटेन मोर वाटर वर्केबल. एन्ड क्ले लोम चाहिँ 20 देखि 45, 15 देखि 53 र 27 देखि 40, 20 15 27, 45 53 40. हाई फर्टिलिटी, गुड वाटर रिटेन्सन, मे बी हार्ड टु स्टिल. एन्ड त्यसपछि गएर स्टिल क्ले लोम्स. ओके, 0 देखि 20, 40 देखि 73 र 27 देखि 40, स्मुथ, रिटेन वाटर एन्ड प्रोन टु कम्प्याक्सन. एन्ड स्यान्ड क्ले 45 देखि 80, 0 देखि 20 एन्ड 35 देखि 55, हेभी सोइल्स, ड्रेन पोरली एन्ड हाई न्युट्रिसन कन्टेन्ट. एन्ड सिल्ट क्ले चाहिँ 0 देखि 20, 40 देखि 60 र 40 देखि 60, भेरी फाइन, फर्टाइल एन्ड रिटेन वाटर, डिफिकल्ट टु टिल. एन्ड क्लेमा चाहिँ 0 देखि 45, 0 देखि 40, 40 देखि 100, भेरी हेभी, पोर ड्रेनेज एन्ड हाई फर्टाइल बट स्टिकी. सोइल स्ट्रक्चर एन्ड क्लासिफिकेसन. डेफिनेसन: soil structure refer to how individual soil practice are arranged and bound together to form aggregate called bed. है त, त्यसलाई भन्छ के भन्छ, पेड भन्छ. इट एफेक्ट वाटर मुभमेन्ट, रुट ग्रोथ, एरिएसन एन्ड सोइल फर्टिलिटी. मेन क्लासेस अफ सोइल स्ट्रक्चर चाहिँ प्लेटी, प्रिज्मेटिक, कोलुमनार. प्लेट छ, प्रिज्मेटिक छ, कोलुमनार, ब्लक, ग्रानुलर, यति है त. प्लेटी, फ्ल्याट प्लेट लाइक युनिट होराइजन, फ्ल्याट प्लेट लाइक युनिट. फ्ल्याट हुन्छ, प्लेट लाइक युनिट हुन्छ, हराइजन्टल्ली ओरिएन्टेड हुन्छ। त्यसपछि गएर कमन इन सब सर्फेस सोइल, यो चाहिँ सब सर्फेस सोइलमा कमन हुन्छ, कज बाई कम्प्याक्सन अर लिचिङ। एन्ड प्रिज्मेटिकमा चाहिँ भर्टिकल कोलम्स विथ फ्ल्याट अर स्लाइटली राउन्डेड हुन्छ, फेस राउन्डेड मोस्टली फेस हुन्छ, मोस्टली इन बी होराइजनमा हुन्छ है त। प्रिज्मेटिक चाहिँ प्रिज्मा बी होराइजनमा हुन्छ, प्रिज्मा बी। त्यसपछि सिमिलर टु प्रिज्मेटिक, कोलमनार चाहिँ सिमिलर टु प्रिज्मेटिक बट राउन्डेड टप vertical face and subsoil affected by sodium accumulation, columnar block even a block like or polyhedral unit, block like or polyhedral unit found in subsoils and clay rich subsurface soils and small crop like and rounded or polyhedral unit and common in surface soils of grassland and garden, rich in organic matter and maintenance of soil fertility and effect of vegetation. Soil fertility चाहिँ the capacity of soil support healthy plant growth, providing essential nutrients, water and a favorable environment for sustained crop yield. Okay, त्यसपछि गएर supply adequate nutrient and water in poor portion, free from toxic substance that inhibits plant growth. त्यसपछि maintain of soil fertility, use of organic fertilizer, compost and manure, incorporation of crop residual or animal manure and cultivation of green manure crops, legume for nitrogen and organic matter. त्यसपछि गएर चाहिँ त्यसपछि गएर composite techniques, mixing plant residue, mature soil and waters and vermicomposite using earthworms and use of chemical fertilizer with necessary effect of vegetation on soil property चाहिँ physical, chemical and biological मा चाहिँ physical को improve soil structure, color, aggregation, porosity and color. Chemical मा चाहिँ enhance cation exchange capacity and buffer pH change. Biological provide nutrient and energy for microbes and high plant. Soil organic matter चाहिँ organic component of soil including fresh plant residue, living soil organisms, decomposing organic matter and stable organic matter भने humus भयो. Decomposition of plant residue भने crop residue decompose returning carbon and nutrient soil, enhance soil aggregates stability and improve soil structure and development of humus चाहिँ dark stable organic matter forms from the decomposition of plant and animals. Formation process चाहिँ disintegration of organic substance and minerals, transformation into new stable component with the help of microorganisms, bacteria, fungi, nematodes and earthworms. त्यसपछि improve soil fertility, structure, water retention and nutrient cycles, improve of microscopic organisms हैन. त्यसपछि microscope, earthworm and insect, नै मिक्स साल इन्हान्स एरिएसन डिकम्पोज रेसिड्यू इम्प्रुभ स्ट्रक्चर होइन माइक्रोब्स ब्याक्टेरिया फङ्गी एन्ड नेमाटोड्स ब्रेक डाउन अर्ग्यानिक म्याटर फिक्स नाइट्रोजन रिसाइकल न्युट्रिएन्ट प्रडक्ट ह्युमस फर्मेसन डिपेन्ड्स अन ह्युमस फर्मेसन के कुरामा डिपेन्ड्स हुन्छ भन्दा टेम्परेचर वाटर ह्युमिडिटी बडी कम्पोजिसन त्यसपछि माइक्रो पपुलेसन फर द फर्मेसन अफ सोइल फ्लोइङ प्रोसेस इज इसेन्सियल के डिस्ट्रक्टिभ्स वेदरिङ पार्टिकुलरली बाई प्यारेन्ट रक disintegration decomposition parent rock disintegration and decomposition and formation of regolith pedogenic process र mature soil particles plus rock fragment constructor by biochemical process profile development improve of microscopic and microscopic organism in soils. Soil organisms are classified into microorganisms, organisms visible to the naked eye, and microscopic organisms require magnification for observation. And microscopic soil organisms example mites millipedes, spider, scorn pines, beetles, earthworm, and ant. Mid and aerate the soils, improving porosity, decompose plant and animal residue, and contributing to organic matter from matter formation. Stabilize soil structure by creating aggregate, enhance soil fertility by aiding nutrient cycles, and microscopic soil organisms example bacteria, algae, fungi, and protozoa. Role regulate nutrients flux to plant, facilitate nitrogen fixation, enhancing soil fertility, decompose organic and inorganic pollution, cleaning the soils, act as natural soil engineering, contributing to soil formation and ecosystems balance. And soil composition, the four major components of soil are mineral 45, organic matter 5, air 25 र water 25, soil solid र pore space, and empirical estimation of stream flow, runoff and water flow structure. Stream flow discharge में definition volume of water flowing through a rivers or stream per unit times meter cube per second or commas, also called discharge of runoff. And method of estimation empirical stream flow estimation. Rational formula is Q is equals to CIA, where Q discharge meter cube per second, runoff coefficient and depends on land use and soil. I is equals to rainfall intensity mm per hectares per hour, and A is equals to watershed areas hectares, and U is equals to U is equals to quick estimation of peak flow, and area velocity where a cross sectional area of the channel and average velocity of flow meter per second. Take multiple velocity reading across the channel for accuracy. And Manning formula 1 by n r को power 2 by 3 s को power 1 by 2 b flow velocity meter per second, r hydraulic radius m र s is equals to channel slope. N is equals to meaning roughness coefficient. Use predict flow in open channel, good for known channel geometry. And gauging wire special notch structure place across stream. Measure water depth over the wire to calculate discharge. Current meter method measure flow velocity at specific point. Multiple reading used to calculate overall discharge. Float method चाहिँ measure surface velocity using a floating object, multiply by channel width and average depth to estimate flow. And estimation of runoff volume and yield. Runoff volume water flowing over land after rainfall. And runoff yield runoff per unit area of watershed. Runoff yield is equals to total runoff volume watershed areas. And steps are collect rainfall land use slopes soil types vegetation data and calculate total rainfall volume. And determine effective rainfall person contributing to runoff. And calculate runoff volume using model or empirical equation. Compute runoff yield. And water flow regulating structure. water flow regulating structure चाहिँ catchment pond चाहिँ store runoff recharge groundwater. Weir and plumes WEIR weir and plume measure and control stream discharge. Retaining wall prevent slope failure and soil erosion. Check dam reduce velocity trap sediment and stabilize small stream. And enhance embankment भने protect against flooding and back cutting. Spur भने चाहिँ redirect flow water or eroding bank. And spillway and cuts भने safety convey excess water to downstream area. Downstreams are okay. Method of son of discharge estimation डाइरेक्ट मेथड र इन्डाइरेक्ट मेथडमा डाइरेक्टमा चाहिँ एरिया भेलोसिटी मेथड र डाइल्युसन मेथड एडियु चाहिँ एडियु भने डाइरेक्ट मेथड हो. एससीएस भने अब डाइल्युसन मेथड एरिया भेलोसिटी मेथड डाइल्युसन मेथड इलेक्ट्रोम्याग्नेटिक मेथड र अल्ट्रासोनिक मेथड यी चिजहरू डाइरेक्ट मेथड भएर इन्डाइरेक्ट मेथडमा चाहिँ हाइड्रोलिक स्ट्रक्चर वेट्स फ्लुम्स नच इटिसी स्लोप एरिया मेथड. वाटर फ्लो रेगुलेसन स्ट्रक्चर डिफिनेसन structure designed to control divert or maintain water flow in stream river channel or pipes to prevent flooding erosion and ensure optimum water use. And common type हरु चाहिँ dams large structure across river for water storage hydroelectric power irrigation and flood control. Words भने low barrier to raise upstream water level and measure flow. And types rectangular binocs trapezoidal. And plumes भने engineered channel for precise measurement of water flow. And types partial palmer bolus yes plumes. And look raise or lower boat between water level also regulate flow. Spillway भन्नाले release excess water from reservoirs to prevent overtopping, sluit gate भने movable barrier to control water flow in canals and or treatment systems, and channel and culvert direct water away from road or agriculture land, leaves and flood walls, embankment to prevent flood water for spreading, and check dam भने small dam in stream to slow water and reduce erosion and deposit sediment, and breakwater and groiness coastal structure and controlling waves, erosion and sediment flow. erosion control structure भन्नाले revetment, gabion and riprap to stabilize river bank and slopes. function चाहिँ control flow, prevent flooding, reduce erosion and support irrigation and maintain ecological balance. catchment pond मा चाहिँ definition constructed pond detection retention bands to collect and store storm water runoff. purpose चाहिँ flow prevention, erosion control, water quality improvement, groundwater recharge, common in urban suburban area with high runoff. purpose determine the flow discharge in river stream for water resources management, flood forecasting, irrigation and environmental monitoring. and method and structure चाहिँ words चाहिँ engineer barriers with a NOx water level over crest used to calculate the discharge. type चाहिँ rectangular, VNOx and trapezoidal, suitable for small to moderate flow. plumes चाहिँ man-made open channel with known cross sections, and water level measure for discharge. type में parcel, palmer bowls and S film, suitable for large flow, high accuracy. and comparison चाहिँ words simpler, basic measurement, and films चाहिँ more precise, consistent measurement and suitable for large flow range. okay त्यसपछि गएर retaining wall चाहिँ a wall built to resist the lateral pressure of soil backfills deposited behind it, support fill and cut slopes economically, prevent small scale shallow collapse, support other slopes, protection works stone boulder, and prevent erosion or collapse at the toe of large scale slopes failure, and support road and canal embankment. classification of retaining wall based on machines of performance principles. types gravity retaining wall support soil by its own dead weight made of loose stones and masonry gabion. and semi gravity retaining wall partially reinforced yellow reduced wall size. cantilevers retaining wall made of reinforced cement concretes. and counterfort retaining wall चाहिँ RCC wall with vertical slab, base slabs and counterfort at regular interval of backfill site. and based on construction material चाहिँ ड्राई स्टोन मेसनरी चाहिँ चिपेस्ट हुन्छ, हाई अप टु 3 देखि 4 मिटरसम्म हुन्छ, फ्लेक्सिबल एन्ड वेल ड्रेन हुन्छ. मोडरेट स्टोन मेसनरी वाल आयो. रिगिड ग्राभिटी वाल, सिमेन्ट मोटर युज, एन्ड फाउन्डेसन अफ हार्ड ग्राउन्ड ह्याभ has webbed walls and 75 mm is 2 to 3 meter square. Composite masonry wall चाहिँ combination of cement masonry and dry stone panel 0.6 to 1 meter चाहिँ हुन्छ। त्यसपछि economical, good drainage storage than dry stones but weaker than cement masonry. And Gabion wall चाहिँ made of wire boxes filled with stones and flexible, suitable for wet poor foundation soil. And cement concrete wall RCC cantilever, counterfort or buttressed types costly, required technical skills. And crib wall चाहिँ made of timber, bamboo and or precast RCC flexible, resist minor differential settlement. And check dam चाहिँ a small low dam built in a gully or water course to reduce water velocity, minimum channel score, promote sediment deposit. And type of check dam in Nepal चाहिँ Brucewood check dam and made of wooden poles and brush, least permanent, low cost, suitable for gullies 1 to 2 meters deep. And loose stone check dam चाहिँ made of loose stone rocks and stability depends on rock size and construction qualities, common in area with abundant stones. And boulder check dam made of large boulders, strong and stable, use where boulders and are abundant. Gabion check dam, okay, Gabion check dam made of wire mesh box filled with stones, flexible, preferred where boulders are unavailable. Masonry check dam made of cement concrete, rarely used, protect important infrastructure like road buildings. And type of check dam advantage and disadvantage चाहिँ ब्रुसवुड र लुज स्टोन, बोल्डर, ग्याबियन, मेसोनरी। ब्रुस लुज बोल्डर भयो, त्यहाँबाट ग्याबियन मेसोनरी। टाइप अफ check dam simple and low cost, use local material, gain strength over time and take long time to establish. And loose stone simple, low cost, use local stones, weak if poorly constructed, inefficient, effective without sizable stones. Boulder चाहिँ simple, low cost, use local materials, durable if well built, difficult to transport, large boulder, large void may create water jet है त, may create water jets causing erosion. And ग्याबियन चाहिँ फ्लेक्सिबल एन्ड पर्मिएबल हुन्छ, सुइटेबल वेयर ल्यान्ड मास इज मुभिङ, कस्टलियर, रिक्वायर एक्सटर्नल मेटेरियल्स, स्किल लेबर निडेड. एन्ड मेसोनरी चाहिँ पर्मानेन्ट एन्ड सोलिड हुन्छ, एस्थेटिक एपिरियन्स हुन्छ. एन्ड कस्टली, रिक्वायर्ड एक्सटर्नल मेटेरियल्स and need good engineering design and skilled labors. Also called revetment, structure built along river to confine river flow and permanent flooding. Selection factor, material availability and use of local resources. त्यसपछि गएर structure built in river to redirect flow away from vulnerable area, eroding bank and usually perpendicular to river bank and often built in series of three or more. Toy protection apron is provided to prevent scoring at spur end, and a common type in Nepal is bar spur, T-shape spur र sloping and spur function चाहिँ deflect गर्छ flowing water and channel, reduce velocity of flow near the bank, prevent bank erosion, establish desirable channel width, and encourage sediment deposition by reducing flow velocity. Spillway अब छ spillway है त hydraulic structure for controlled discharge of water from a dam or embankment, prevent overtopping and catastrophic dam failure during flood or high water level, release excess water safety into demonstrate area usually riverbed and short चाहिँ inclined or vertical channel to guide the gravitational flow of water. Two types, long shots and short shots. Function guide downstream water flow, prevent accumulation of high water velocity, and reduce erosion in downstream areas. Difference from spillway shots, regular water flow control, spillway specifically for excess water flow management, and culvert design, a tunnel like hydraulic structure to convey water under road, railway or embankment, prevent washout, flooding and erosion, and crucial for transport safety and water management. Design considerations चाहिँ hydrological characteristics of the area and flow capacity and velocity, structure availability, and type of culvert चाहिँ बक्स कल्भर्ट, पाइप कल्भर्ट, आर्च कल्भर्ट र मल्टिपल कल्भर्ट. बक्स कल्भर्ट चाहिँ रेक्ट्याङ्गुलर हुन्छ, स्ट्रङ हुन्छ, ड्युरेबल हुन्छ. पाइप कल्भर्ट चाहिँ क्रियोसियल सर्कुलर हुन्छ, फ्लेक्सिबल हुन्छ, कमन फर स्मल स्ट्रिम हुन्छ. आर्क कल्भर्ट चाहिँ आर्क सेप्स हुन्छ, स्ट्रङ हुन्छ, एस्थेटिकल्ली बेटर हुन्छ. मल्टिपल कल्भर्ट चाहिँ कम्बिनेसन अफ फर लार्ज फ्लो हुन्छ. हाइड्रोलोजी precipitation, rainfall and water movement चाहिँ hydrology derived from hydro water and logo study, scientific study of water occurrence, distribution and movement. ODM of earth on earth, cover water into atmosphere, surface and subsurface in liquid, solid and gaseous form. Hydrological cycle चाहिँ water cycle, continuous cycle with no fixed beginning or end. Key process precipitation, evaporation or transpiration. Precipitation water falling from atmosphere to earth. Evaporation liquid water to vapor from surface भइहाल्यो. Transpiration चाहिँ water loss from plant, and evapotranspiration, combine evaporation plus transpiration. Infiltration water movement into soil. Runoff water flow over land surface to streams. Groundwater flow and storage, water moving below surface, and stream flow in river and channel. त्यसपछि गएर any water liquid or solid falling from atmosphere to earth, crucial for replenishing lake, river, groundwater from rain, snow, sleet, freezing rain and drizzle. Measurement चाहिँ rain gauge, heightometer, pluviometers, and type of rainfall, convectional rainfall र orographic रेनफल र साइक्लिक र फ्रन्टल रेनफल क्लाउड जस्तो लाग्छ कज बाई हिटिङ अफ अर्थ सर्फेस वार्म एयर कोल्ड रेजेज कोल्ड कन्डेन्स र रेन हुन्छ कमन इन ट्रपिकल रिजनमा हुन्छ चाहिँ कन्भेन्सनल रेनफल ट्रपिकल रिजनमा एन्ड समर आफ्टरनुन ओरोग्राफिक टोपोग्राफिक रेनफलमा चाहिँ मोइस्ट एयर लिफ्टेड ओभर माउन्टेन कुल्स कन्डेन्स एन्ड रेन हुन्छ पछि मोस्ट रेन फल्स चाहिँ अपविन्ड अफ माउन्टेन रेज हुन्छ एन्ड साइक्लिनिक फ्रन्टल रेनफल चाहिँ कज बाई कोलिजन अफ वार्म एन्ड कोल्ड एयर मेसेस प्रेसर डिफरेन्स लिफ्ट एयर रेन कमन इन टेम्परेचर रिजन एन्ड ड्युरिङ cyclone and rainfall intensity. Okay, rainfall intensity rate at which rain fall over an area per unit time mm per hour or in per hour impact flooding soil erosion agricultural productivity water resource management classification usually light moderate and heavy depending per hours and interception चाहिँ water caused by vegetation or structure before reaching soil reduce direct runoff and increase evapotranspiration and evapotranspiration ET भने combined water loss from soil and evaporation plus plant transpiration major component of water cycle influence soil moistures and water balance and runoff water that flow over the land surface into river lake and reservoir determined by rainfall intensity soil type and infiltration capacity slope and land cover and vegetation movement of water into and through soil is infiltration बाट पर्कुलेसन बाट क्यापिलरी फ्लो बाट र ग्राउन्ड वाटर फ्लो बाट infiltration water enter into soil surface percolation water move downward through soil layer to groundwater capillary flow भने water movement in small pores towards plant root and groundwater flow भने slow movement through aquifer towards stream or rivers and water yield भने चाहिँ quality of water that can be collected from a watershed include surface runoff groundwater contribution र important for irrigation drinking water and hydropowers rainfall intensity classification by intensity mm per hectares light rain moderate rain heavy rain र very heavy rain र extreme rain चाहिँ लाइट एकदम लाइट रेन चाहिँ 2.5 mm per hour भन्दा सानो 0.1 inch per hour चाहिँ हुनु पर्यो 2.5 to 7.6 7.6 to 5 to 100 7.6 to 50 to 100 भन्दा माथि per hour 0.1 0.3 inch देखि 0.3 0.3 to 2 mm 2 inch 2 देखि 4 र 4 भन्दा माथि है त मोडरेट भने 2.5 to 7.6 mm 0.1 to 0.3 inch per hour heavy rainfall 7.6 to 50 mm per hour 0.3 to 2.0 inch per hour very heavy rain 50 to 100 mm per hour 2.0 to 4.0 inch per hour extreme rain 100 भन्दा mm भन्दा माथि per hour र 4.0 inch per hour भन्दा माथि per hour types ड्रप साइज ड्रिजल रेन र हेलस्टोन 0.5 mm भन्दा कम छ भने ड्रिजल र रेन चाहिँ 0.5 देखि 6 mm छ भने रेन हेलस्टोम 8 भन्दा बढी छ भने हेलस्टोन rainfall intensity is key for flood prediction soil erosion water resource planning and agriculture and difference classification help design hydraulic structure drainage system and irrigation planning and interception evapotranspiration and runoff and infiltration percolation and water yield and hydrology key concept चाहिँ interception definition precipitation that is captured by vegetation leaves branches litter and does not reach the soil types canopy interception leaf litter interception canopy interception rainfall caused by leaves and branches and rainfall caused by fallen leaves and forest floor litter through fall water reaching the ground directly through gaps in the canopy stream flow water flowing downstream and trunk to reach the soils evapotranspiration definition combined process of evaporation from soil and water bodies transpiration from plant formula in forest is et is equals to IL plus E plus T IL भने interception loss capacity plus canopy plus leaf litter E भने evaporation and T भने transpiration important influence watershed water yield and affected by forest and land management above runoff definition portion of precipitation flow over land surface and infiltration formula चाहिँ runoff precipitation and runoff भने precipitation minus infiltration significance चाहिँ importance for flood prediction water resource planning and soil erosion control infiltration छ definition process by which water enter the soil surface factor affecting infiltration भने soil को type vegetation land use and soil moisture and percolation भने movement of water through saturated soil layer under gravity movement of water through saturated soil layer under gravity difference from infiltration भने infiltration is equals to entry into soil अनि percolation is equals to downward movement through soil's profile and water yield भनेपछि average amount of fresh water discharge from a water formula चाहिँ total water yield is equals to surface runoff plus groundwater flow plus tile flow minus transmissional loss okay अनि water balance equation भनेपछि P plus S win plus S win P plus SW in plus GW in minus ET minus SW out minus SW out is equals to के त हाम्रो change in storage P भने precipitation SW in र SW out भने surface water inflow र outflow र GW in र GW out भने ground water inflow र outflow and ET भने evapotranspiration S भने change in storage purpose ensures hydrological accounting of water in watershed and watershed prioritization principle and springs management चाहिँ watershed prioritization भने systematic approach to identify and rank sub watershed or area within a large watershed based on ecological, hydrological, social and economic characteristics. Purpose: guide decision making, allocate resources efficiency and ensure sustainable watershed. And need for watershed prioritization: district have multiple watershed of different size but limited resources. All sub watershed cannot be managed simultaneously due to financial and human constraint. Prioritization ensure efficient resource utilization and selection of key programs. And general characteristics for prioritization: hydrological characteristics चाहिँ precipitation pattern, runoff potential, soil types, groundwater recharge, flow patterns and help in water availability management चाहिँ flood control and water quality protection. Ecological important मा चाहिँ biodiversity, habitat quality, endangered species, role of forest and watershed, protect and restore vital ecosystem. And land use and land cover चाहिँ agriculture, urban area, forest, natural vegetation, help identify stress area and potential for erosion control and water quality improvement. सोसियोइकोनोमिक फ्याक्टरमा चाहिँ population density, agriculture, infrastructure, local livelihood, prioritization area critical for human well-being and economic activity. Erosion and sedimentation मा चाहिँ assess erosion rate and sedimentation potential, important for preventing sedimentation in river and river reservoirs. And threat and vulnerabilities मा चाहिँ population, deforestation, climate change, land use change and focus in most vulnerable area for conservation. And stakeholder चाहिँ stakeholder engagement include local communities, government, NGO and other stakeholders, ensure successful implementation and sustainability. And cost benefit analysis भने evaluate potential benefit of intervention and allocate resource to area with highest return on investment. Multi-criteria decision analysis MCDA, multi-criteria decision analysis integrate multiple factors to rank sub-watershed based on overall importance. And principle of watershed prioritization: utilize land according to its capability, protect fertilized topsoil, minimize siltation of reservoirs and lower fertile land, protect vegetation cover throughout the year, and promote in situ conservation of rainwater, ensure safe diversion of surface runoff to storage, focus on land reclamation and soil erosion prevention. And process of water prioritization: obtain information on biophysical and population characteristics of sub-watershed. Biophysical characteristics 60% weightage, use 1:50,000 topographical maps to delineate sub-watershed हैन 15 देखि 25 km square is prepared land use erosion potential LUEM, land use erosion potential maps, prepare land system erosion potential maps LSEP, land system erosion potential map, prepare erosion potential composite map, erosion potential composite map, calculate erosion prone area and estimate land use land use, land system erosion potential value. Land use, land system erosion potential value. Calculate sub watershed biophysical value. Sub watershed biophysical value. पपुलेसन क्यारेक्टरिस्टिक्समा चाहिँ 40% वेटेज इस्टिमेट पपुलेसन क्यारेक्टरिस्टिक्स 40% वेटेज estimate subwatershed population density numerical value. Okay, subwatershed population density numerical value. And combining biophysical and population data, subwatershed prioritize cumulative value. Subwatershed prioritize cumulative value is equals to subwatershed BPB plus subwatershed PD and B. अब यो चाहिँ यहाँ माथि हेर्नु पर्यो सब वाटरसेड पपुलेसन डेन्सिटी न्युमेरिकल भ्यालु र सब वाटरसेड बायोफिजिकल भ्यालु हैन सब वाटरसेड प्रायोरिटी कमुलेटिभ भ्यालु इज इक्वल्स टु दुवैको प्लस हुनु पर्यो र्याङ्किङ चाहिँ सब वाटरसेड एरिया एरेन्ज डिसेन्डिङ बाई सब वाटरसेड के त priority cumulatives value and is equals to higher priority for management activity integrated approach of watershed management. अब के को integrated watershed management is a comprehensive and coordinated approach treating the entire watershed as an unified entity. Consider ecological, social, economic and institutional aspect, recognized interconnectedness of water, land and vegetation and humus activity, sustainable and effective watershed management, focus in emphasize on resource conservation and rational utilization of land and water. M. Support economic development without environmental degradation. History. Integrated development project introduced by UNDP in early 1960s. Integrated watershed management concept evolved in Nepal during 1970s. Department of Forest and Soil Conservation 3 level planning हुन्छ जसमा level of planning reconnaissance level planning, broad general approaches, determine possibility and potential using general and qualitative info, applied on national and regional level, semi-detailed level planning, more specific approach, collect semi-quantitative and semi-qualitative info, determine project feasibility and watershed, prioritization at district level, detailed level planning, high specific planning, use quantitative and qualitative data, prioritize watershed or sub-watershed based on detailed info, basic step of integrated watershed planning, identify problem, recognize need and estimate objective, and collect data and information, analyze and review data and information, formulate plan, implement plan and monitor and evaluate. Key element principle of integrated watershed management watershed assessment, stakeholder involvement, land and water conservation, water resource management, biodiversity conservation, watershed planning, monitoring and evaluation, policy and governance, education and awareness, adaptive management हैन यो चाहिँ emphasize on resource conservation and utilize of land and water. M. Support economic development and without environmental degradation. History. Integrated development project introduced by UNDP in early 1960s. Integrated watershed management concept evolved in Nepal during 1970s. Department of Forest and Soil Conservation 3 level planning हुन्छ यसमा. लेभल अफ प्लानिङ चाहिँ लेभल अफ प्लानिङ चाहिँ रिकन्सिनेन्स लेभल अफ प्लानिङ, ब्रोड जनरल एप्रोच and determine possibility and priorities using general and qualitative info applied on national or regional level. Semi detailed level मा चाहिँ more specific approach, collect semi quantitative and semi qualitative info, determine project feasibility and watershed prioritization at district level. Detail level planning मा चाहिँ highly specific planning, use qualitative and quantitative data, prioritize watershed or sub-watershed based on detailed information. And basic step of integrated watershed planning ma identify problem, recognized need, estimate object, collect data and information, analyze and revive data and information, formulate plan, implement plan, monitor and evaluate. And key element and principle of integrated watershed management or watershed assessment, map land use, vegetation, soil and hydrology, and identify environmental issue and challenge, and engage local community, government, NGO, private sector, academia, ensure local need are met and support is obtained. Land and water conservation, soil conservation, erosion control, prevent sedimentation, measure buffer zone, reforestation, afforestation and sustainable agriculture, and water resource management चाहिँ efficient water use, rainwater harvesting, recycling, demand management, and balance water for agriculture, industry and domestic use while protecting ecosystem, biodiversity conservation, protect and restore natural habitat, maintain water quality, regulate water flow, support livelihood. Watershed planning चाहिँ गर्दाखेरि develop comprehensive watershed management plan and include scientific data, modeling, community input, objectives, target and timelines, monitoring and evaluation, and take effectiveness of activities, identify issue, make informed decision, policy and governance, strength institutional framework and policy, ensure clear responsibility, coordination and resource allocation. Educational awareness में raise awareness on importance of watershed management and sustainable practice, adaptive management, maintain flexibility and adaptability as watershed are dynamic. Outcomes of integrated watershed management चाहिँ enhance water security, mitigate natural disaster impact, promote sustainable livelihood, promote environment for present and future generation. Springside management is a specialized branch of water management, focus on the preservation, protection and sustainable use of spring and their surrounding area. Spring are natural outlet of groundwater that supply water to communicate and water to community and evaluate ecosystems. Spring head the area where hydrological and ecological process sustain spring flow. And key principle of component चाहिँ hydrogeological understanding and study geological formulation, groundwater flow, permit and recharge and discharge process, crucial for understanding sustainability spring. And source protection चाहिँ protect spring and rich area from contamination and over extraction. And measure चाहिँ buffer zone, land use planning and pollution control, and conservation of catchment area चाहिँ maintain the entire catchment maintain the entire catchment that recharge spring, ensure sustainable groundwater supply, reforestation and vegetation management चाहिँ vegetation regulates groundwater recharge and prevent soil erosions, practice reforestation, proper land management and include of local communities, engage communities in management activities and utilize traditional knowledge and local cooperation, sustainable water use हैन sustainable water use चाहिँ promote water conservation practice at the community level, maintain balance between water demand and availability, monitoring and data collection, track spring flow, groundwater level and water quality, provide data for adaptive management and decision making, policy and governance चाहिँ establish clear policy, regulation and governance mechanisms, ensure effective protection and sustainable use, capacity building and awareness, trail local stakeholders and raise awareness about importance of spring set and conservations and research and innovations, promote research and new technology for spring head management, lead to improve practical practice and outcomes, objective and outcomes चाहिँ secure and reliable water supply, promote ecosystems, enhance community resilience to environmental change, promote holistic and sustainable management of spring and their catchment, upstream downstream linkage. अब अपस्ट्रीम एन्ड डाउनस्ट्रीम लिङ्केजको कुरा गरौँ, रिफर टु द इन्टरकनेक्टेड रिलेसनसिप बिट्विन अपस्ट्रीम एन्ड डाउनस्ट्रीम एरिया इज अ वाटरसेड अर रिभर बेसिन, इम्पोर्टेन्ट फर वाटर रिसोर्स फ्लो, इकोलोजिकल ब्यालेन्स एन्ड ह्युमन वेलबिङ्स, अन्डरस्ट्यान्डिङ लिङ्केज इज क्रुसियल फर इफेक्टिभ रिभर बेसिन एन्ड वाटरसेड म्यानेजमेन्ट, require community level knowledge for sustainable management. त्यसपछि गएर environmental service ecosystem services. Ecosystem services are function and benefit that ecosystem provide the human and nature, essential for ecological balance, human well-being and sustaining life. Type of ecosystem service चाहिँ provisioning service है, direct resource from human survival and livelihood, example food, crop, fish, wild fruit, game, animal, water चाहिँ filtration, storage and supply for drinking and irrigation, raw material चाहिँ timber, fiber, minerals and medicines, र regulating service मा control environmental processes and maintain ecosystem health and example चाहिँ climate regulation, forest sequestrate carbon and release oxygens, flood regulation, wetland reduce flood risk, pollination, insect and animal support agriculture and biodiversity, water purification, vegetation filtered, pollutant flow, water bodies, cultural service मा aesthetic, spiritual, recreational benefit, aesthetic, spiritual, scanning scanning landscape, cultural important and site, recreation, park, forest and beaches, cultural identity, traditional practice, ceremony and heritage and supportive services मा चाहिँ supporting service मा fundamental to ecosystem functioning supports and example soil formulation, essential for plant growth, nutrient cycle, carbon, nitrogen, phosphorus cycle, biodiversity maintenance, support ecosystem resilience and genetic resources, ecosystem service trade off and synergies हैन, ecosystem service trade र synergies. अब trade-off. Improving one service may negatively affect another. Example, dam construction. Improving one service may negatively affect another. Example, dam construction increase energy provision but reduce fish population. हैन, ड्याम कन्स्ट्रक्सन इन्क्रिज इनर्जी प्रोभिजन बट रिड्युस फिस पपुलेसन. अब सिनर्जिज, इम्प्रुभ वान सर्भिस बेनिफिट अदर सर्भिस. इम्प्रुभ वान सर्भिस बेनिफिट अदर सर्भिस. Example, wetland restoration improve water purification, flood regulation and habitat provision. हैन, सिनर्जी भने के भन्थे, इम्प्रुभ वान सर्भिस बेनिफिट वान सर्भिस, इम्प्रुभ वान बेनिफिट अदर सर्भिस. एक सर्भिस चाहिँ इम्प्रुभ गरेपछि अदर सर्भिस चाहिँ पनि बेनिफिट हुन्छ भन्दा. इक्जाम्पल चाहिँ वेटल्यान्ड रिस्टोरेसन गरेपछि इम्प्रुभ वाटर प्युरिफिकेसन र फ्लड रेगुलेसन पनि हुन्छ र एन्ड ह्याबिटाट प्रोभिजन पनि हुन्छ है त. स्टेप्स फर एनालाइसिस, आइडेन्टिफाई इकोसिस्टम सर्भिस, क्लासिफाई इन्टु प्रोभिजनिङ, regulating cultural and supporting service, assess interaction, determining direct indirect relationship between services, trade-off analysis, identify service negatively impact by environment of another, synergy analysis, identify service positively affected by enhancement of another, and payment of environmental service चाहिँ. And equitable benefit sharing, payment for environmental service is a mechanism where beneficiaries of ecosystem service pay upstream communities for conserving ecosystem, ensure fair compensation for resource protection. Upstream downstream linkage are critical in linking the Chure upstream and Tarai downstream regions. Upstream forest and watershed provide water, soil protection and biodiversity. Downstream Tarai benefit for clean water, educates, flood, fertile soil and irrigation. PES, payment for ecosystem service, encourage upstream communities to protect forest and watershed and promote equitable sharing of economic, social and ecological benefit between upstream and downstream stakeholders. Summary key points चाहिँ, upstream activity directly affect downstream water availability, soil quality and ecosystem service. Ecosystem service include provisioning, regulating, cultural and supporting services. Payment for ecosystem service link beneficiaries downstream with providers upstreams for sustainable management. Equitable benefit sharing ensure fair compensation and long-term cooperation. Understanding trade-off and synergies is essential for sustainable balance and watershed management. अब upstream and downstream linkage, environmental service, payment for ecosystem service and equitable benefit sharing सुरे तराई कन्टेक्स्ट को हेर्नु पर्यो है त. सुरे तराई कन्टेक्स्ट को हेर्नु पर्यो. सुरे तराई कोड अपस्ट्रीम एन्ड डाउनस्ट्रीम.